Good morning, and here is a video key for Geometry Exit Ticket 20.1. I've blown it up a little bit so it's easier to draw on. So here we go. Of course, love to hear some of your thoughts here, and y'all are in different places, of course, but everyone seems to be moving forward, so that's good. Let me know how that went. You're going to need this. You needed this in the do now. You're going to need this again for the exit ticket. The postulate, this is the PAI postulate, or pairs of alternate interior angles postulate. Postulates are things we can assume, similar to straight lines make straight angles. So if two parallel lines are cut by a transversal, this is a transversal, each pair of alternate interior angles are congruent. So 1 and 2 are congruent. And of course, a reminder that these little marks here indicate parallel lines. If you had another set of parallel lines, you might double up on these marks for a second set to distinguish it from the first set. So using the PAI postulate and other concepts on the diagram and the given, use them all to make a case for Theorem 27 here. So Theorem 27 simply says if two parallel lines are cut by a transversal like that, each pair of interior angles on the same side, these are not alternating interior angles, these are same side interior angles, so each pair of those are supplementary. Okay, so we've been given that A and B are parallel. You can assume that from the diagram also because they have been marked as such. And we're supposed to prove that angle 3 is supplementary to angle 5. So after the givens, we can say that we probably should label some other stuff. So I'm going to label this angle here, and I'll call it 4, just because I need to come up with a name. So angle 4, according to the PAI postulate, is congruent to angle 3. So angle 4 is congruent to angle 3 by because it is an alternate interior angles to each other. Okay, that's the PAI postulate. And then with that, then we can say angle 4 is supplemental to angle 5. Angle 5, because they make a straight angle together. Okay, and then we can say that angle 5 is sup to angle 3 because angles that are sup to, congruent angles are sup to the same angles. That's probably worded badly. But basically what I'm getting at is since angle 4 is supplementary to angle 5 and angle 4 is congruent to angle 3 is sup to angle 5 because angle 3 and angle 4. It's basically a variation of the transitive property there. So now we're going to use PAI postulate and other concepts. By the way, you could have just done this with some algebra too. You know, we could call this x and we call this x because they're the same x degrees, and then this could be 180 minus x. So 180 minus x will be supplementary to this and supplementary to this. Okay, so use the PAI postulate and other diagrams to make a case for Theorem 28 here. Okay, so here's what we've got. We've got this given and this given. A and B are also parallel lines. So we can say given, okay, and then we can add some angles in here. So we can call this one 2, and let's call this one 3. Okay, so this is going to involve some transitive property, I believe. But we can say that angle 2 is congruent to angle 1 by vertical angles. Okay, and then we can say angle 2 is congruent to angle 3 by the PA, because they are alternate interior angles. And then we can say that angle 3 is sup to angle 7 because they make a straight angle. And then we can say that angle 7, let me move this down a little bit. So angle 7 is sup to angle 1. We can just say by transitive property or substitution if you wish, because we could just substitute angle 1 and angle 3. The measures of those angles are the same, so or substitution could be used. Okay, so there you have it. That's 4B. And now 4C, we're dealing with some similar stuff. Here we want to, we're dealing with the theorem. Let me go back to the theorem 28. We've just done a nice demonstration of if two parallel lines are cut by a transversal, each pair of exterior angles on the same side, not exterior alternate angles, exterior angles on the same side would be supplementary. By the way, this implies that alternate exterior angles would be congruent too, which is a later theorem. And use the PAI postulate and other concepts in the diagram to make a case for theorem 29. So theorem 29 says, in a plane, if a line is perpendicular to one of two parallel lines, it is perpendicular to the other. So we've got this one defined as perpendicular here. Okay, so we've got this diagram. I apologize for a little choppiness there. I had to address a question. So I've got a perpendicular situation here. This is right angle. These are parallel lines. We're going to try and prove that line C is perpendicular to line B. We've been given that line C is perpendicular to line A. I'm going to scroll down a little bit so I'm not running up against this stuff. So there's some things that we can say pretty quickly. So we've got the givens, and then we can say, and we're going to go ahead and label some angles. I'm going to label this 1, and I'm going to label this angle 2. Okay, this one will be a pretty simple one. So we can first say that angle 1 is congruent to, I guess, the right angle in the givens. I should have given that a number, but that's okay. And so angle 1 is right. Okay. Angle 2 is congruent to angle 1 because they are alternate interior angles. PAI, pairs of alternate interior angles. I should say they are a pair. That's probably the best way to say it. A pair of alternate interior angles. Now, finally, we can say that angle 2 is right by transitive or substitution. Either one, you can make a case either way. Okay, because if angle 1 and angle 2 are congruent, then angle 2 is congruent to this angle over here. Or you could say if two angles are congruent to, if an angle is, if this angle, so an angle that is congruent to two different angles, those two angles are congruent. I cannot remember which theorem that is, but that's essentially a thing that you can say. And I hope that that gives you what you need. There are a variety of ways you could have said